In this lesson, we're going to go through fission and fusion, both terms you've probably heard before. So fission means to split. So when we talk about splitting an atom, this is what we're talking about. So fission occurs when you have a heavy nucleus and it splits into two smaller, more stable nuclei. That's initiated by bombarding the nucleus with a neutron. So here is our heavy nucleus. This is our neutron right here. And we're going to approach this the exact same way that we were approaching the decay problems. So what I'm going to do is I'm going to add up all of the protons on both sides to make sure that all of those numbers are equal. And now if you notice, we have something new here. So when we have a 3 in front of the neutrons, that's like saying we have 3 neutrons. So on the left side, we have 92. 92 plus 0 is still 92, equals 56 plus some number plus 3 times 0 is 0. Okay, so 92 minus 56 is 36. And let's go ahead and do the same thing on the top. So you've got 235 and 1, 141, and 3 times 1 is 3. So 235 plus 1 is 236. And then we have 141 plus some number plus 3. So 236 minus 141 minus 3 gives us 92. So when I write this out, we're going to have 92 on the top, 36 on the bottom, and then if I look up 36 on the periodic table, that is krypton. All right, here's another example. So same thing. We're going to take a look at all of the number of protons, make sure those are equal, and then we'll do the same thing with the number of, or with the mass numbers. So we're going to make sure those are all equal. Okay, so let's start with the protons. 92 plus 0 is 92. We have some number here, plus 35. 3 times 0 is 0. Okay, so 92 minus 35 gives us 57. And then on the top here, 235 plus 1 is 236. That's going to be equal to some number plus 87 plus 3 times 1 is 3. So 236 minus 87 minus 3 leaves us with 146. So if I write that out, we're going to be 146 over 57, and that's going to be LA. All right, here's another example. Again, still approaching this the exact same way. So 92 plus 0 is 92. That's going to be equal to 55 plus some number plus 2 times 0 is still 0. 92 minus 55 is 37. And then for the mass, 235 plus 1 is 236. 138, and 2 times 1 is 2. So 138 plus some number plus 2. So 236 minus 138 minus 2 is 96. So we have 96 over 37, and that is rubidium, Rb. Okay, so fission chain reactions occur when we have multiple reactions happening in a row. So each neutron emitted by the fission of a nucleus can cause another fission reaction. Okay, and again, this is what's called a chain reaction. So in a nuclear power plant, the control rods absorb neutrons so the reaction doesn't grow uncontrolled. So with the Chernobyl disaster, they weren't able to control the rate of the reaction, and it happened really fast. A lot of energy was generated, and the rest is history. So let's take a look at a diagram and see what this looks like. So if you look on the diagram here, we have this first reaction. So the neutron hitting the nucleus, that causes a release of energy. So that's thermal energy, heat. And we've got 3 neutrons being kicked out here. Those neutrons then hit another nucleus. So we have a separate reaction right here, here, and here. And then that grows, and it repeats the process. So it gets bigger and bigger and bigger. And again, that's called a chain reaction. Okay, so fusion means to join. This occurs when 2 smaller nuclei combine or fuse to form a larger, more stable nucleus. And this mainly occurs in stars. So we're talking about our sun here. So again, we want to make sure everything's balanced. So on the left side, 1 plus 1 is 2. On the other side, we have 2 plus something. Well, this is going to have to be 0 for that to balance correctly. With mass, 2 plus 3 is 5. That's going to be equal to 4 plus some number. Well, that some number has to be 1 for that to balance out. So this will be 1 over 0, which, if you recall, is a neutron. Here's another example. So we've got 1 plus 1, that's 2. On the other side, we have 1 plus something. Well, that has to be a 1. Up above with the masses, 1 plus 1 is 2. That's going to be equal to 2 plus some number. Well, that number has to be 0. 0 over positive 1, if you recall, is positron emission. All right, let's take a look at one more example here. Same thing, still top and the bottom. So 1 plus some number equals 2. Well, that's got to be 1. And then on the top, 1 plus some number equals 3. That has to be 2. Okay, so we look up number 1 on the periodic table, that's hydrogen, and that's it. That's fission and fusion. Who would have thought? It's that easy.